Imagine the endless, snowy desert of Wyoming, where the wind howls so fiercely that it seems capable of tearing the skin off your face. In the middle of this white hell stand two buildings, a modern log cabin and a trapper's hut, blackened by time, built a century and a half ago. When the storm subsides, the modern house, designed by engineers and assembled with laser precision, will be warped or destroyed under the weight of the snow. The old shack, built by an illiterate settler with a single axe, will stand as firmly as it did on the day it was built. Modern builders rely on metal fasteners and rigid fixings, forgetting the ancient laws of working with wood. Frontier pioneers had no room for error because the price of poor construction was measured not in money, but in the lives of an entire family in a single frosty night. Their homes were not just shelters, but complex mechanisms that used gravity and wood shrinkage to their advantage. Watch the video to the end, and you will learn how the absence of nails made the structure eternal and why gaps in the walls were the key to survival in severe frosts. What if I told you that everything you believed about the strength of immovable structures is not true? We are used to thinking that a reliable house is one that stands monumentally and does not move, like a stone fortress or a concrete bunker. However, in the Wild West, attempts to build wooden houses based on the principles of stone construction led to disaster in the very first winter. The secret of the old masters was understanding that a felled tree continues to live its strange life, constantly changing shape and volume. A log is not a brick. It breathes, absorbs moisture from the air, and releases it back, expanding and contracting depending on the season. The frontiersmen knew that it was useless to fight this movement, and instead of fighting, they learned to dance with it. If you try to fasten the logs tightly together, nature will tear your house apart at the first temperature change. The house had to be a dynamic system that allowed each element to find its place under the sun and snow. It was like a living organism that adapts to external pressure rather than trying to resist it. Modern log houses are often assembled using rigid metal pins that pierce the wall from top to bottom, turning the wood into a kind of reinforced concrete. When the wood begins to dry out, these metal rods prevent the logs from settling, and huge gaps appear in the walls. In old huts, the logs lay loosely, and gravity was the only glue that made the wall denser over the years. The more time passed, the more the house was pressed, closing off any possible paths for cold wind. The shrinkage of the house could reach 15 centimeters per meter of height, and this was considered a completely normal process that had to be taken into account in advance. Windows and doors were installed in special sliding boxes that did not interfere with the walls settling. A large gap was left above each opening, filled with soft moss, which compressed as the house sank. If a pioneer forgot this rule, the settling logs would simply crush the window frames to splinters or hang on them, forming holes. Errors in calculating shrinkage cost settlers dearly, often resulting in the roof leaking and the chimney collapsing. Pioneers used only logs that were available in the nearest forest, and these were often green wood. Building with green wood was considered risky, but people often did not have a year or two to dry the material. Therefore, the entire structure of the house was designed specifically for the logs to dry in the wall, changing their geometry. The skill lay in predicting how a pine or larch trunk would behave in 5 years' time. The builder had to possess intuition bordering on clairvoyance to understand the character of each individual log. They alternated between butt ends and tops so that the wall would rise evenly, despite the natural curvature of the trees. This approach to construction required a deep respect for the material and a complete rejection of attempts to bend it to one's will. Unlike modern standard materials, each log was an individual with its own quirks and flaws. The art of survival on the frontier lay in the ability to turn these flaws into advantages, creating a structure that became stronger over time. I'm very interested to hear your point of view. What do you think about a construction philosophy that allows for movement and change rather than rigid fixation? Write about it in the comments.
The humble axe was the key tool for frontier builders, creating joints with precision they often surpassed.
Are you ready to learn the truth about why simple axes created joints more precise than modern machines? A house on the frontier always held together because the angle determined the fate of the entire structure. People chopped not only for strength, but also for the precision of the wood's contact. The axe was an extension of the craftsman's hand and allowed him to feel the wood, not just cut it. That is why hand chopping was not as rough as it seems. It was smart and predictable as a result. The corner lock of a log house was not just a way to connect two logs. It was a system with a logic that went deeper than the fibers of the trunk and the plane of the cut itself. Intelligent cutting took into account the future shrinkage of the wood, which cannot be stopped but can be used to one's advantage. Such joints were made so that they would work on their own without constant adjustment or iron fasteners. It was an engineering design that had been tested by time, not by instruments, and it was extremely practical. When the wood dries out, it changes shape, but the correct lock only becomes stronger than at the beginning. The craftsman deliberately made inclined planes that allowed the upper log to find its place again and again. Unlike a simple bowl, the corner did not open up but increased the grip under load and shrinkage. This was the principle of self-locking construction, which was later given an engineering term, but people were already living by it. The corner of the house jammed itself if the walls pressed down with their weight or the earth, and that was the secret. In our story, modern builders often use round bowls at the corners because they are quicker and easier to cut, but they have found that wood shrinkage causes such bowls to open up. When a log dries, its diameter decreases and the corner begins to move slightly. In the Middle Ages and on the frontier, this was understood immediately. A moving corner means moving air, and moving air means a cold night. Therefore, the bowl was supplemented or completely replaced with other locks. As soon as the round bowl dried out completely, it became a vulnerable spot in the house. The wind could easily stitch the corner, and the microclimate of the room collapsed in literally minutes. People noticed this immediately. If it pulls on your feet, it pulls on your life. On frosty nights, the open corner turned into a channel for heat and moisture loss at the same time. Therefore, on the frontier, such bowls were considered a dead end in the evolution of locks, not an ideal, and people felt it. Pioneers more often used a dovetail or saddle-shaped lock with an internal spike. The spike became the center of adhesion, which helped the geometry work in both directions of pressure. The inclined planes around the spike were designed so that the embrace of the corner was strengthened when the wood lost moisture and shape. These shapes and slopes provided for the drainage of water and wind at the same time, which was important all year round. The house became stronger precisely at the corner core, where loads and heat converged. And this was a technology without iron. The geometry of such locks really worked in tandem with the drying of the wood. When the wall pressed down with its weight, the corner wedged more tightly than it had been during assembly. With each season, the wood dried out, but the pressure did not weaken. It was only redistributed by the logic of the cut. People did not notice the movement with their eyes, but they noticed that the wind had no chance of passing such a corner without a corridor. It was a mechanism that was repaired only in the fall so that they could immediately enter the winter protected. And they usually did. The secret lay in the inclined planes of the lock, along which the upper log moved downwards under the constant logic of its own weight. It was a slow, invisible mechanism that did not stop day or night. The angle of the house worked like a natural sliding screed without metal, controlled by gravity, shrinkage, and the logic of the cut. Water did not linger because the planes did not allow it to remain inside the spike for long. The cold wind also could not rise along the inclined cuts, and the house lived. When people realized that planes could be sloped rather than flat, the house became more logical than the ocean of winds on the frontier. The corner adjusted itself to the changes in the wood, saving firewood, sleep, and people's health at the same time. That is why later on entire buildings were moved without dismantling the corners. The corner was stronger than the entire wall assembly in terms of material. Craftsmen considered this the norm, not a miracle, because it worked more often than dismantling each log. So they chopped for a long time, but wisely. Even the corners of tenons and saddle-shaped locks were often treated to resist wind and rain with colossal density. The corner with the tenon held air, water, pressure, and the load of the roof. People repaired the walls around it, but the corners of the opening were not touched more than once a year. This ensured not only warmth, but also stability under changes in the structure of the building mixture, and the house was not drafty. The decay of corners was the main cause of the destruction of wooden houses. This was known in the Middle Ages and was later confirmed by excavations and old preserved fragments of houses. A corner cut by hand with an axe could resist decay much longer than a sawn end. If water and wind could not get in, the corner survived. If they could, the house died. Therefore, the axe and time always work together. Modern machines do indeed provide geometry, but they do not feel the trunk, the direction of the fibers, and the internal tension of the wood. The axe closed the pores of the wood with a blow, rather than cutting them with a saw blade as a machine does. The blow did not just cut, it stabilized the cut surface, making it denser and more stable. In the Middle Ages, craftsmen did not simply cut the corner, they polished it with each blow, and this saved the house from cold and damp. Have you ever seen a real log house built without a single nail that has stood for over 100 years? Want to know a secret that will change your life and your perception of warmth? There were always gaps between the logs, and what was used to fill them determined the fate of the house. On the frontier, materials were chosen not from a catalog, but based on availability, shrinkage behavior, and reactions to moisture. The wood in the log house lived, settled, and slowly twisted, and builders accepted this as normal. Therefore, the insulation had to be flexible, responsive, and easily replaceable. The gap itself indicated whether flexibility, density, or water drainage was needed. Modern craftsmen often rely on assembly foam, but in the harsh climate of earlier times, this was not an option. In the Middle Ages, in villages and new territories, the main task was to retain heat at night and prevent rot during the day, all with a minimum of materials. Wood reacts to moisture and shrinkage, so synthetic materials with a strong bond would be a dead end. Natural fibers and moss worked much more predictably. The builder put the cycle above the elements. Pioneers most often used caulking made of clay, sand, and ash. The ash absorbed excess moisture, the sand stabilized the mixture, and the clay did not crumble immediately after application. Such materials lasted a long time if they were renewed in the fall. Later, archaeology confirmed that this mixture was the most stable in northern dwellings, with proper grooves and windbreaks. The human body felt the house as a vessel more strongly than it appeared visually. But caulking was not just a construction process. It was a ritual and a method of survival. If it was not renewed, the gap would become a corridor for wind and dampness. If renewed correctly, the house would become warmer inside. Craftsmen preserved the mortar in advance so that the corner would not become a point of loss. This was determined by experience, without instruments. Bison wool, horsehair, or coarse fibers from available textiles were sometimes added to the clay. This created a framework inside the putty itself, which prevented the mixture from cracking immediately in the cold. Hair and wool absorbed moisture more slowly and allowed the mortar to remain warm when touched against the wall. People were not afraid to lean against such a wall at night. The heat settled more gently. It was moss that was the real core of insulation in the interlog space. It did not spoil, did not expand sharply when wet, did not lift the logs in the groove. It was also a natural antiseptic because it blocked the wind and prevented moisture from collecting in large puddles in the groove. This was a technology of natural distribution that had been felt for generations, and it saved lives. Medieval peasant dwellings also often included W grooves or double contact points, even with the simplest hearths. The groove was more important than whitewashing or decorations. It created a chamber of still air along the entire wall from which the heat did not jump anywhere. Instead of glue, clay, moss, and hair were used. The fire worked in a cycle. Sometimes the airlock between the logs was closed with strips of skin, old cloth, felt, or burlap soaked in animal fat. The fat not only insulated, it also stitched the fibers of the mortar into a soft barrier against moisture and wind. The seams were not always whitewashed, but the fat was always used. It was a cold filter, better than the synthetics of the time, and people trusted it more. The craftsmen inspected the house in advance, feeling for every place that had been punished by the wind. A gap in the groove was considered a task. The doorboards, walls, and threshold were repaired in layers, not in terms. The corner was fate. That was the rule. The timing of repairs was not discussed, because those who waste their emotions on the cold lose their body and sleep at night. Conversations took place closer to the hearth. The wood worked with its breath, the furniture maintained the temperature, and the gap should not be a corridor. This logic was considered the norm. The W-shaped groove created 2 points of contact between the logs and held a stationary air chamber between them. This chamber retained residual heat longer than any monolithic but sawn groove. If the wood moved, the groove slipped but did not tear. If the mixture was alive, the house lived. If the groove was incorrect, no mortar could save it from the wind. Beginners sometimes made the mistake of filling the walls with materials that expanded quickly when exposed to rain or snow. But experienced craftsmen did things differently. They dried the mortar in advance and laid moss at the end before winter. The wind was not supposed to get through to the core of the house. By morning, people felt that even the law of current flow across the floor depended on the door no less than on the hearth. The threshold joints were covered with a double roll of fabric or moss so that every bucket and piece of firewood would not take away the microclimate of the room. This is how they saved the winter. Otherwise, the house would listen. A person on the frontier would find it strange to build a groove without consulting the shrinkage and slopes. They did not build quickly, but repaired on time. The house lived on clay and moss just as the body lived on porridge and fat in winter. It was a symphony of simple solutions. Compare this with modern houses that do not know the natural inertia of materials and heat zoning. Then the difference in the logic of architecture and temperature distribution becomes obvious. The house must breathe, and the bubble must go outside, not stay inside. That is why the old log house lived and did not accumulate dampness. Guess what happened next when tons of snow fell on the frontier roofs? The roof was the most vulnerable part of any building, and it was often the cause of death for unprepared settlers. In modern frame houses, the rafter system is a complex web of thin boards fastened with metal plates. This design is designed for certain loads, but it does not have a margin of safety in case of extraordinary events. The huts of the Rocky Mountains were built with the expectation that snow could lie on the roof for months, turning into solid ice. The pioneers used a log construction where powerful horizontal logs were cut directly into the gables of the house. A continuous floor of poles or split boards was laid on these rafters, and a layer of turf or bark was laid on top. The key difference was the absence of thrust pressure on the walls. The heavy roof simply pressed vertically downwards. In modern roofs, the rafters tend to push the walls apart, and if the fastenings break, the house collapses like a house of cards. In a pitched roof, the more snow that accumulated on top, the denser and more stable the entire log house became. The angle of the roof was also carefully calculated and compromised between wind load and snow. A roof that was too steep shed snow well, but turned into a sail in the strong winds typical of the plains. A roof that was too flat could not withstand the weight of wet snow in the spring, when the load increased many times over. The roofing material also played a huge role. Cedar or larch shingles lasted for decades without any impregnation. These types of wood contain natural oils that repel water and are unattractive to wood-boring insects. Modern bitumen tiles become brittle in the cold and can be torn off by strong gusts of wind. Turf roofs, popular in the plains, were also excellent insulators, keeping the house warm in winter and cool in summer. A half-meter thick layer of earth dampened the noise of the wind, creating silence inside the hut even during the fiercest storms. However, such weight required the use of solid trunks of century-old trees as load-bearing beams. Modern engineers often save on the cross-section of beams, relying on calculation tables and the strength of the wood grade. Settlers, on the other hand, always chose wood with 3 times the strength because their instinct for self-preservation replaced the tables. They knew that the mountains could see snowfall so heavy that no city architect could have imagined. The roof overhangs were made deliberately long to divert water as far away from the walls and foundation as possible. This protected the lower crowns from rotting and created a dry space around the house for storing firewood. The short overhangs of modern houses leave the walls unprotected from slanting rain and wet snow. The base of a frontier house rarely resembled what we today call a foundation. Pioneers did not have the means to pour concrete strips or drive piles to the depth of frost penetration. They built their houses on large flat stones, placed only at the corners of the log cabin and at the intersections of the walls. This seemed primitive, but in fact, this system provided ideal ventilation for the subfloor. The wind blew freely under the floor, drying out the moisture that inevitably rose from the ground. Modern continuous foundations often create stagnant areas where radon and moisture accumulate, destroying the lower crowns. The support stones were not rigidly connected to the ground, which allowed the house to float during seasonal soil heaving. If the ground rose at one corner due to frost, the house simply tilted slightly but did not crack. A rigid concrete foundation in such conditions often cracks, which then tears the walls of the house. The lowest crown, or foundation, was made of the most resinous and hardwood they could find. Often it was oak or larch, which practically do not rot even in direct contact with a humid environment. This crown was considered a consumable material. It was structurally separated so that it could be replaced after 50 years. Modern houses are built as if they will stand forever without repair, which is a dangerous illusion. The pioneers knew that the bottom log would rot, and they built it so that replacing it would not require dismantling the entire roof. The floor in such huts was often earthen or made of logs split in half on planks. The earthen floor was warm but dusty, so it was often watered and tamped down to the hardness of stone. Wooden floors were not nailed tightly to the joists, allowing the boards to move and dry out. Gaps in the floor also promoted ventilation and allowed debris to fall through, making cleaning easier. The lack of waterproofing between the wood and stone was compensated for by the quality of the wood itself and ventilation. Modern roofing felt or films often trap water inside the wood, accelerating the rotting process. Old craftsmen relied on the openness of the structure to allow the sun and wind to do their sanitary work. The height of the crawl space was minimal, so that in winter, snow would cover the floor and insulate the house from below. In summer, the floor was raked, restoring the draft under the house. It was a simple but effective climate control system that relied on the owner's muscle power. Errors in the foundation were fatal. If the bottom crown rotted, the house began to tilt and crumble. Therefore, the selection of stones in the first log was a sacred ritual marking the beginning of construction. Everything above depended on these 4 points of support.
The settler understands that proper ventilation is key to keeping the fire alive and the cabin safe from carbon monoxide.
What if everything you've been taught about heating efficiency is outdated? Modern houses are built on the principle of a thermos, to retain maximum heat by completely eliminating the inflow of cold air. In frontier conditions, where the only source of heat was an open fire, such an approach would lead to death from carbon monoxide poisoning. The hut had to be airtight enough not to cool down, but permeable enough for the stove to work. A huge stone fireplace or cast iron stove consumed a tremendous amount of air for combustion. If the house was airtight, the stove would begin to suck air out of all the cracks with double the force, creating icy drafts. Or worse, the draft could reverse and smoke would enter the room, killing the sleeping people. Balancing the flow of fresh air with heat retention was a delicate art of survival. The massive stone masonry of the fireplace acted as a heat accumulator, absorbing the heat of the fire and releasing it throughout the long night. Even when the fire burned out, tons of heated stone continued to radiate gentle warmth until morning. In modern frame houses, there is no thermal inertia. As soon as the heater is turned off, the temperature drops rapidly. Log houses, on the other hand, thanks to the mass of the logs, cooled down very slowly, smoothing out daily temperature fluctuations. 30-centimeter thick logs warmed up during the day and gave off heat at night, acting like a battery. The fireplace was always located in the center or against an interior wall, so that the chimney would heat the house, not the street. It was a mistake to attach the fireplace to an exterior wall, where precious heat was lost to the cold outside. The chimney was made as straight as possible so that soot would settle less and the risk of fire would be minimal. During the most severe blizzards, life in the hut centered around this source of heat within a radius of 2 meters. The far corners of the house could freeze over with frost, and this was considered normal. Water in a bucket by the door could freeze while the fire was hot. The temperature zones within a single room forced the body to harden and adapt. Sleeping places were located either very close to the fire or on lofts under the ceiling, where warm air gathered. Downstairs near the floor, it was always cold, so the beds were made high. Modern heating systems strive to create a uniform temperature throughout the entire space, which is comfortable but energy intensive. On the frontier, only the space where people were at the moment was heated. This was a strategy to save energy for gathering firewood, which took up a huge amount of time. Fire safety was a constant nightmare. A spark from the chimney could set the dry roof on fire. Therefore, during a blizzard, when the wind could blow sparks under the eaves, people took turns watching the stove. Could you keep the fire and life going in such conditions when warmth is only a step away from the stove? The settlers understood that a house does not begin with the first log, but with the choice of a point on the map. The location was chosen as if it were the most important decision of their entire lives. People knew that a plot of land could either become a shelter or a trap of cold and wind. A mistake in choosing a location could cost much more than a mistake in construction. Therefore, they walked around, examined, waited, tested the soil, and observed the sky. It was a strategy for survival, not construction. Modern people choose plots because of the view of the valley or convenient access. In the 18th and 19th centuries, aesthetics gave way to the right to life and peaceful sleep. A panoramic view of the cold lowlands was considered beautiful but dangerous. Convenient access without taking into account the wind corridor meant nothing. People first sought protection from the elements, then access. This rule was understood with the body, not the mind. Safety from the wind meant safety for strength and warmth. Settlers looked at the terrain as a map of air currents. Where the wind walks, life is harder. Where the air stands, heat accumulates better. The external beauty of a place was not worth the warmth in winter. This knowledge was a norm that was applied, not declared. Building a house at the bottom of a valley by a river was considered a mistake comparable to suicide. People saw traces of past floods on the ground and tree trunks, and they knew that the water would return again. The lowlands might be quiet during the day, but at night the frost would slide down there. By this logic, a house at the bottom would lose not only heat but also health. Cold air is heavier than warm air and flows downhill on frosty nights. This effect was later confirmed by meteorologists, but people knew about it long before science did. In the valleys, the temperature could drop sharply and without warning. The cold was measured in minutes, not degrees. People went upstairs, frost went downstairs. The temperature difference between the bottom of the valley and the southern slope could reach 10 to 15 degrees. This was verified by human experience. The higher you were, the milder the night. The lower you were, the harder it was to breathe and sleep. This was evident every winter. The logic was not debatable, it was physical and obvious. The southern slope of the hill was called the sunny shelf, not for its beauty, but for the physics of light. A house facing the sun lasted longer and was warmer from dawn. The sun heated the wall, which then transferred the heat to the air. It was free heat, valued more than gold. The further south the face was, the longer the heat lasted. This sunny side later became a place for conversation and sleep. People cleared the line of light to the hearth in advance. The south wall always contributed to the microclimate. The north wall did not. This was the physics of the era. Summer was also taken into account. Cold areas were not chosen in summer either, because dampness and insects interfered with life. In the summer, mosquito swamps appeared below, which the average settler avoided like the plague. Wealthy people could build houses higher up, but the peasants had more control. The north wind must always remain outside. The lowlands were most often prone to sudden floods in the spring. In the spring, melting snow turned the river into a different force, heavy and destructive. A house could fall victim to a single flood. Therefore, a house down below did not mean a house. A house on the shelf did. First, builders protected the house with the terrain, then with fire. The terrain was the first shield, fire was the second, and everyone knew this. The forest around the house was cut down not only for materials, but also to prevent trees from falling during storms. In the Middle Ages and on the frontier, storms were a real force that could not be ignored. They tried to clear the area so that the roof would not become a trap for people at night. The wind could break trunks, but not the roof. The space was made quiet but observable. However, on the leeward side, a strip of trees was left as a windbreak. This was a rare exception to the rule of clearing the forest. The windward side of the site was specifically protected from gusts. The windbreak strip was part of the architecture of warmth, and people knew it. The trees held the wind, not the cold. If the cold came with the wind, there was a windbreak for that. If the wind came with the cold, there were walls for that. It was a natural technology. The orientation of the house to the cardinal points was strict. People understood that winter light, although short, could be collected as a resource. The entrance and windows most often face south or east, where the sun rises earlier. A blank north wall was the norm, not the exception. It was a zone for combating the cold. Even wealthy settlers ignored windows on the north side because the north wind was too destructive for the microclimate. Panoramic north windows were not found in the Middle Ages, precisely because it was a thermal mistake. The house lived where the wind could not defeat the heat, and a north window would give away the heat immediately. The west side was also often made blind. The west wind brought winter cold faster than the smoky hearth could accumulate air. In summer, the western sun heats the house too sharply, creating dryness and temperature differences. In other words, the west punishes the house with temperature in both seasons. Therefore, the west was closed off. The floors in houses were often made of earth or mixed with clay so that they could also help to accumulate heat. Earthen floors absorbed heat later, but gave it off more slowly. People did not lay thin boards there because boards cool down quickly. Mats, baskets, workbenches, and fabric were laid on top to slow down the loss of heat from the floor, and it remained above zero. Sometimes the house was half built into the hillside. Dry earth actually heated the house better than wood. This provided a stable pocket of above zero temperature, but took away daylight. However, people considered this an acceptable drawback because the main thing was to sleep, not to see the walls. This is how semi-dugouts were built, which were the warmest on the frontier, and this was later confirmed by archaeologists. Earth retains heat better than air. In spring, the house protected against flooding in the same way as it did against the wind in autumn. Melting snow rose and could flood the site if it was too close to the river. Traces of flooding were the main marker of danger. Better a meter uphill than a meter in water. That was the main rule. The best source of water had to be accessible, but not too close to the bottom of the valley. Water was not kept near the house in winter, but the path to it was kept short and painless in terms of warmth. It either went downhill to a stream or to a hole in the ice, but the house stood above the traces of flooding, and that was safe. The Middle Ages and the frontier shared this knowledge. A house without control of airflows is not a house. Therefore, cracks in doors were repaired in the fall, and materials were heated in advance. This saved breath with every entry, and the body did not shiver. Building materials were chosen with a care that would seem fanatical today. Not every tree was suitable for logging, and not every time was suitable for harvesting. Modern logging operates year-round, driven by delivery schedules and profits. The pioneers knew that trees should only be cut in winter, during the coldest frosts, when sap flow has stopped. Winter wood was dry, dense, and much less prone to rot and cracking. The moisture in the trunk was frozen out and the pores were closed, making the wood rock hard. They chose condominium pine or larch trees that grew in dense forests or on poor northern soil. The annual rings of such trees are so dense that they are difficult to distinguish with the naked eye. Such fine-grained wood has incredible strength and resistance to moisture. Modern forests, grown on plantations with fertilizers, grow quickly and have a loose, sponge-like structure. Such a house will rot in 20 years, while a hut made of century-old pine will last for 150. The resin in old trees impregnated the trunk throughout, serving as the best natural antiseptic. The harvested logs were always sanded down. The bark was removed so that bark beetles would not infest them. Leaving the bark on was considered a lazy and dangerous practice that quickly led to the destruction of the walls. The logs were often stacked for a year or two so that they would shrink before being laid in the wall. But in the rush to develop the frontier, buildings were often constructed from freshly cut timber, taking into account future shrinkage. Trees of approximately the same diameter were used so that the walls would rise evenly. The curvature of the trunks was compensated for by the skill of the logger, who turned the logs with the hump facing upwards. The underside of the log where the groove was cut had to be flawless, without knots or rot. Knots are hard inclusions that interfere with a tight fit and can fall out over time. Each trunk was inspected and tapped with the back of an axe to determine its quality by the sound it made. A dull sound meant internal rot, and such wood was ruthlessly discarded for firewood. Building a house from diseased wood means infecting the entire structure with rot. The pioneers could not afford the luxury of rebuilding their houses in a couple of years. Some old craftsmen believed in the influence of the phases of the moon on the quality of wood, harvesting timber during the waning moon. It was believed that then the wood warped less and did not absorb moisture. This combination of practical experience and mystical beliefs created a unique approach to the material. Respect for wood was absolute. Cutting down a centuries-old giant for a temporary structure was considered a sin. Each log had to serve people for centuries, justifying the death of the tree. Modern carpenters cannot imagine construction without kilograms of nails, staples, and metal plates. Metal gives the feeling of quick and reliable fastening, the illusion of control over the structure. But in the context of a log house, metal is a foreign body that conflicts with the nature of wood. The main problem with metal is that it acts as a cold bridge, allowing frost to penetrate deep into the warm wall. Condensation forms on the surface of the cold nail inside the wood, and this water begins to destroy the wood. Over time, a hidden source of rot forms around each metal rod. In addition, metal does not contract and expand with the wood when humidity changes. A tightly nailed board will sooner or later crack or pull out the nail when the log decides to change shape. In old log houses, wooden dowels were used, spikes made of hardwood. The dowel worked as a single unit with the wall, expanding and shrinking at the same rate as the logs. This ensured the monolithic nature of the structure without internal conflicts between materials. Nails were an expensive and scarce commodity on the frontier and were saved for horseshoes, doors, and furniture. The use of nails in the load-bearing structure of the roof was also limited. Everything was held together by notches and gravity. If the roof is assembled with nails, then in strong winds, the nails work to shear and may not hold. The notch, on the other hand, transfers the load from tree to tree, and it is much more difficult to break such a connection. Modern mistakes include rigidly attaching vertical posts to horizontal walls. When the log house settles, these posts turn into jacks that suspend the crowns and form gaps. Pioneers used screw jacks, if available, or wedges that were knocked out as the house settled. Another mistake is the use of vapor-proof films and paints that lock moisture inside the logs. Wood must breathe, releasing moisture to the outside. Otherwise, it will rot in a few years. Old cabins were never painted with oil paint. They turned gray and black, creating a natural protective layer. The interior finish also had to allow the walls to move. No rigidly screwed plasterboard. Plaster, if used at all, was applied to laths, which had some flexibility. The whole philosophy was based on flexibility in the absence of rigid connections. The irony is that the absence of industrial fasteners made the settlers' houses more technologically advanced from a physical point of view. The shortage of metal forced people to use their minds and geometry instead of brute force. They did not fight against the nature of wood, but used its characteristics to strengthen the structure. Survival in a blizzard depended not only on the thickness of the walls, but also on the organization of the space inside. Frontier huts were small, often only 4 by 5 meters, and this was a conscious decision. It was practically impossible to heat a large space at -40 degrees with wind with a single stove. Cramped quarters were the key to warmth. A small volume of air heated up faster and was easier to retain. Low ceilings prevented warm air from rising too high, keeping it in the living area. Doors were made low and narrow so that a minimum of precious heat was lost when entering and exiting. The front door often opened inward in case it was buried under snow taller than a person outside. If the door opened outward, the residents could find themselves walled up in their own home after heavy snowfall. Strong bolts and shutters on the windows protected not only from the wind, but also from bears or uninvited guests. There were few windows, and they were tiny, often covered with oiled parchment instead of expensive glass. Glass was a poor insulator, and heat would escape instantly through large windows. The light in the house was dim, but that was the price to pay for surviving the winter without frostbite. Psychologically, such a hut was a fortress, separating a tiny world of order from the endless chaos outside. The thick log walls provided a sense of security that was vital in the wild. The sound of the wind crashing against the log cabin was a reminder that man had managed to carve out a place for himself under the sun. Inside, there was always a supply of dry firewood, water, and provisions in case of a snow blockade lasting several days. Tool, an axe, a saw, a rifle, always hung in a prominent place ready for use. The house was not just a place to sleep, but a tool for survival, a workshop, and a warehouse. Daily life was organized to minimize the need to go outside in bad weather. Even the toilet was often replaced by a bucket in the corner during a storm so as not to lose heat. Life was compressed to the size of a single room where every action mattered. Modern, spacious houses with high ceilings and skylights seem like palaces, but they are helpless without electricity and gas. A trapper's hut was self-sufficient, requiring only firewood in the hands of its owner. It was extremely honest architecture, devoid of embellishments and excesses. It was beautiful in its rough functionality and harmony with the harsh world around it. These buildings outlived their creators, becoming monuments to human perseverance. It was this simplicity and reliability that made it possible to conquer the Wild West, step by step, log cabin by log cabin. We have seen that the survival of frontier cabins in blizzards is not a coincidence, but the result of a deep understanding of the nature of materials and the elements. The pioneers had no room for error. Their architecture was shaped by the experience of survival, where every groove and every stone mattered. Unlike modern technologies that attempt to isolate humans from nature, the old methods taught people to live in harmony with it, using its laws to their advantage. These log cabins, blackened by time and standing in the mountains, are silent witnesses to the fact that true reliability lies in simplicity and flexibility. They remind us that sometimes the old ways, requiring patience and hard work, prove to be the most reliable in the face of real danger. What do you think about the forgotten technologies of the past? Should we return to them in private home construction? Write in the comments what other aspects of the life of pioneers or Native Americans you would like to learn about in future issues. And don't forget to subscribe to the channel so you don't miss new stories about the conquest of the Wild West.